My name is Julie. I'm an engineer at Microsoft, and today I'm going to talk to you about CI/CD when you have both applications and infrastructure. So a little bit about me. As I said, I'm an engineer at Microsoft. I am part of the Fast Track for Azure program, which means I help onboard customers to Azure. Before that, I was an enterprise architect at Allianz Germany, which is a multi-billion-dollar insurance company. And actually, many of the sort of opinions and recommendations that I'm giving you today come from that experience as well as my experience at Microsoft. Before that, I was a full stack engineer. I still am actually, and a designer. So I come from the Mac world, open source. I like Node.js, Ruby. I really don't like Windows. And I'm a very opinionated person. So I will try to mention when, something is my personal opinion recommendation. The photo here I put nostalgically because it was literally the last week of February before a lockdown because of Corona. And so it feels very strange, not just to work remotely without ever having met your colleagues, but also giving a talk right now over video, but seems to work. Okay, so let's start with a very simple example. So today I'm going to give you sort of various use cases. I'm going to try to start simple, and then it gets really complicated really quickly. But the point being, I want to teach you how to fish and not give you a fish when it comes to figuring out CI/CD for yourself. So let's start with the easiest thing possible, right? A mono repo, because we come from, monoliths. Very simple. I'm going to make a push, and a build server will pick it up. So I have Jenkins here. Jenkins is my favorite server of all time, build server. I use Azure DevOps and GitHub Actions as well, but I still prefer Jenkins. Anyway, so let's say I push to the main branch. It's going to deploy to my production environment. Let's say eventually I'm happy. I'm going to somehow on my local computer merge those changes into production, and then I'm going to push the change to production, and Jenkins pushes that over to my production environment. All is good, I think. How do you know it actually works? That's kind of CI, just goes there, it does some tasks, but does it actually work, right? How do you get to the point of continuous delivery? Can you do automated promotion? That is a little bit more complicated than many people expect when they first do it. So we still have the same mono repo, the same sort of monolithic application. We're going to make a push to our main branch, which remember corresponds to our development environment. So Jenkins will have deployed it. It's all done. Let's run some end-to-end tests, right? So in this theoretical example, let's say I have even a single page application that actually has an end-to-end test suite that will fire up a browser, click through everything, and what my end user is trying to do in the application, we can verify that it works as expected. So maybe I can buy a t-shirt, for example. Based on the results of that test, right? If they don't work, then we say, oh, failed, end of job, end of story, end of the build job, that is. Let's say it actually works, right? So what you can do is then have Jenkins make that commit for you to that production branch. So whereas before you might have sort of, by hand went and clicked through everything to make sure it works, you could run an end-to-end test suite and say, okay, I'm confident. Let's put it into production, which will kick off another job, and then we'll deploy it to production. It sounds very sort of simple in practice, right? But it's actually much more challenging than you would expect, right? So it's really, really hard to write tests in general and then to write end-to-end tests. And then for people who have things like credit card processing, et cetera, that they have to do, really complicated. And it's okay if you don't have them. And it's okay, even if you have them, you still don't do automatic promotion. So I don't do automatic promotion most of the time, for example, but that's mostly because I'm not coding every day, just some days. Anyway, let's make it a little bit more complicated. Let's say your application, you've been working on a couple of years and you want to sort of split things out, because we have mobile devices. So you're going to split out your backend. Now we make a change to main, right? Jenkins is going to say, well, what do you want me to do? Am I supposed to deploy the backend, front end, or both? Super confusing suddenly, but how do you fit everything together? And then one of the biggest challenges when you're doing CI/CD, and especially when you're in that phase where you're not used to actually having multiple deployable components, you have so many sort of events and triggers, and okay, Jenkins is going to run a job, but with what code? Why? And so Usually people, they keep track of pushes, which branch triggered was pushed to, what files sort of changed, right? So previously you saw there was a subfolder for front end and there was another subfolder for the back end. There are other triggers that people forget about. So pull requests, super easy way to hack somebody, by the way, because if the pull request actually does a deployment, then I could maybe fork the repo and just make a pull request and I'm in your environment. But I'm a jerk like that because I used to be enterprise architect and I would just find holes in people's software. And in terms of events that can trigger things, right? Because you want to automate based on, you see on the right here, a list of webhook events for GitHub Actions. You see pull requests, you see the review, just a comment on the pull request, which also makes sense. Maybe you want to be like, hey, Julie, you got to go look at this. So because we have so many possibilities, it's actually quite scary how many things we have to keep track of. And then once you've sorted it out in your head, you still have to sort of actually put that in your pipeline, which is, it sounds easy, but it's not necessarily, because if you look at here, I have two examples. So the first one is pretty simple, right? It's Groovy code for a Jenkins file, and it looks like code. It says when, there's some brackets. All right, I'm kind of pretty sure what's going to happen. When you have YAML, right, which is true for many CI platforms, including Azure DevOps and GitHub Actions, it's easy to forget something. The indentation is wrong. Like sometimes you have includes, but wait, I want to exclude because there's some file in there that really shouldn't be triggering a deployment. It's just a README file, etc. And suddenly things are happening, and it also just means everything slows down, right? You have all these jobs that are waiting to run, or you're just spending time figuring out why something is happening when you don't want it to happen. And then remember we said we had now backend and front end, and then you have development and production. So you have 4 suddenly, and you have this one big file here as an example. Okay, when it's the front end in development, do this. When it's the front end in production, do this, right? It might just be the when part. Okay, let's just change some configuration variables. But the point is that you have sort of 4 different cases that you have to worry about. So it gets a little bit just sort of like, what is changing and why? I personally like splitting them up into different files. The build server will also often show like, oh, the front end dev pipeline is running, or the back end production pipeline is running. It's just easier to see. Whereas before you might just see it's deploying. Well, what is it deploying? That's really hard to figure out. So many people don't like this because it's too many files, and there's you're not reusing code and a library, etc. I don't care. So I've been working in the web for 20 years. No, 15 years as a salaried person. And what's most important actually is how long does it take you to debug something? How long does it take you to fix something when something is broken in production? Because that costs you money. So making code sort of nice little libraries is fun. I enjoy doing that as well. But what's more important in terms of priority is being able to fix things and build things super fast. Okay, so the next thing that's complicated now that we split things up, right? So we're also deploying differently. We have to figure out, from the user perspective, I can't buy a shirt anymore for whatever reason. And to sort of track that down, we're going to look at versions. And then you have different ones for front end and back end. But what does that mean for your overall sort of application? However, if you're asking that question, you don't really have sort of the independent services. You thought you were building microservices, but actually what you have is a distributed monolith. So let's say you've kind of figured that out now. You've learned that a little bit. You're going to keep going forward. Now you're going to do microservices. Okay, so I picked the simplest example possible for a microservice. Right, so everybody knows what a calculator is. Let's say now I'm just building the front end. The rest of the services, they do something. I talk to the API. I really don't care. Super easy for me. I just version something. It's right now, the backends are stable, right? Because I'm assuming they do whatever they do, it works. But what's really important to understand is that whether or not something is stable is not a technology problem. It's going to be a people problem. So to illustrate that, let's say the people who are working on Multiply, they're going to do something funky, right? So they make a change and it goes into their development environment, but they don't know if something broke, right? For the user who wants to buy a t-shirt. So what they can do in their pipeline is, let me grab those tests from the front end application and run them. But which version are you running against? So that's also something that's really sort of hard to figure out. And then once you have that test, you can figure, okay, do I move that change all the way through or do I not? The thing is, like, you're looking for that certainty, which you might or might not have. And ultimately, in my experience, what determines whether or not you need end-to-end tests and whether or not you rely 100% on them is sort of the stability of your product, right? So a calculator is super simple, right? It just 1 + 1 is 2. When you're doing insurance, it's a little bit more complicated. And even if the technology doesn't necessarily sort of do what you expect it to do, if the business rules are very clear, it's a bit easier to figure stuff out. Anyway, what's most important is to understand that you talk to each other. That's how you figure stuff out. Even if you don't have those end-to-end tests, or even if you do, go on chat, whatever, go talk to people. Okay, so let's make this a little bit more complicated, right? Because management comes around and says, we need to scale, and we think PaaS services are expensive, platform as a service services. We're going to use Kubernetes. We hear it's awesome. All the cool kids are doing it, and it's super, super cheap. And so you, as a calculator team, suddenly have a cluster, and you're like, this doesn't look so bad. We have to worry about ingress, like we have to do routing on our own and configure it. But actually, it's a little bit more complicated than you think, because suddenly you have multiple, let's say, data stores, right? So you have your container registry for your Docker images, and you also have pipelines as code as well as infrastructure as code. So before, when we were worried about front end triggering backends, right, and which environments, now you have to worry about your infrastructure code triggering deployments as well, which is also kind of like crazy. Too many triggers. So if we look at this sort of case with the mono repo, right, you're just getting started. You can sort of do a lot of learning by doing, but as you can see, it's getting already quite complicated and you need more skills. Kubernetes is not application development. It is so much infrastructure with networking and security that you have to configure yourself. And in some ways, okay, I can, in my sandbox, blow things up, but there is so many things that are so easily blown up. So let's make it more complicated and say your management came around and let's put all those services, right? Your little monolithic calculator, let's put all the microservice ones in a Kubernetes cluster. And you see here, we have different namespaces and different repositories, and boom, way more sort of triggers and events that can happen and that can sort of crossfire. Obviously, it might not be a problem for you, right? You've practiced CI/CD, your domains are stable, but still it can happen. And it's just something that you have to worry about. And you probably will stumble on it for a very long time before you've mastered it. So let's look at infrastructure now, because your management is like now, like, I don't know, they're on some ego trip. We're going to do Kubernetes, all the things. Doesn't matter if it makes sense. It doesn't matter if you're ready yet. We're going to do all the things in Kubernetes. And suddenly you're promoted to a central infrastructure team. So in this diagram, I have 3 different layers, right? So a sort of foundational infrastructure layer, a middle layer that's building like kind of a weird platform as a service for other teams that has the Kubernetes cluster. And let's say the goal of the company is that the application development teams at layer 2, all they do is like kind of like in our previous, the very first story scenario, I make a change, push, done. Everything else will be managed by other people. It's still not that simple, because you have here, for example, I have routing, and then you're going to have TLS certificates because we want secure connections. Then you have the question, wait, who has those certificates, right? How can I get access to them? If they belong to the team, as you see in layer 2 at the top, then I have to be able to, from my cluster, which is in a different layer, actually grab those certificates, right? You're like, oh, I don't want to manage all of that. Let me just put all the certificates with me in layer 0. And that's easier for me to configure. It's, kind of one credential maybe. But then you have all these developers knocking on your door whenever they need to change, whenever something's about to expire or something expired and you didn't update it, and suddenly it's your fault. Whereas if it's their certificate, it's their fault. No matter what, you're probably going to have people knocking on your door, right? Because for things like DNS and routing, that has to be configured. and it's probably central. Like not everybody has access to, your root domain. In most of these examples, app.com. And old school would be fill out an Excel file, email it to me, and one day I will make that record change for you. One day I'll open that firewall part for you. But as you grow as an organization, you can actually use inner sourcing, right? Forking repositories and pull requests to streamline some of that. The last thing I want to mention here is that there is a container registry that we've given to the app team themselves, so that they have control over their own images, that one team can't shoot another team in the foot by accidentally overriding their image, for example. So that's like a security decision that we made. But again, we have the challenge of configuring various Kubernetes clusters to know which container to go to pull an image, and then to be able to have access to pull those images. So backtracking a bit with inner source and code examples. So these are actually 2 examples from open source repositories that I have. So I use Terraform to do infrastructure as code because it's kind of easier to read. And on the left-hand side, you would see an example of how you could do that. You could actually even extrapolate some of the Terraform and just create a variable. So application developer teams, you don't need to know Terraform, right? But anybody who can write a few lines of code in whatever language can read this file and make a change. Similarly, what I want to show on the right-hand side, it's a bad example for inner source. But the question of security, right? What you don't want to do is suddenly have client IDs and client secrets, so like kind of usernames and passwords, floating around all over the place. Never mind the fact that they eventually expire as well. And so there are ways to get around that, right? So your cloud provider might offer something like managed identities, as we do in Azure. And you can see here that I'm just passing references to something. I don't know what all those credentials are, and I don't need to know it. I'll do other things and role assignments, and Azure will figure that out for me. What I kind of want to say is that this is really, really hard. It's super, super hard. In this diagram here, I'm talking about end-to-end governance, because what you'll often have is when people go to the cloud, they'll say, we locked everything down. You can't deploy anything to, so I talk about Azure, but it could be AWS or GCP, Google Cloud Platform, whatever. It's all locked down. The developers can't do anything. But they forgot about CI/CD. Especially these companies that are new. They're like, yeah, we're on the DevOps train. It's like, can the contractor deploy, push to the production branch? Yeah. That's not a problem. And so if you look at this diagram, there are various places with little red locks as well, because you can configure secrets in various places. You configure branch protections in various places. Like I want to prevent that contractor from deploying to the production branch. I have to be able to configure that. And who has the permission to do that? Because if the contractor can do that, then, well, guess what? You didn't fulfill your security rules. So aside from infrastructure, right? Like this is super, super complicated. And it's complicated because of the people, not because of technology per se. You can make it worse with technology. You can make it worse with Kubernetes because it's not really app dev. But the biggest takeaway that I want to give you is that it's all about the people, right? It's a lot about the experience of the people. So it's not about, I want to hire senior folks. People will have those skills. People can learn those skills. You can invest in them and give them the chance to learn it. And the advantage that you have there is that they're learning it with your business domain, right? So I'm very fortunate in retrospect, to have started with insurance, which is super, super complicated, because now smaller things like a shop are kind of easy for me to do. All the things about coupling and the dependencies that you have, the technical limitations will really just be a reflection of the business rules that you have. And some of them you don't determine, right? So I come from a compliant industry in insurance, and security says you have to do things this way. You have to treat a contractor this way. I don't want to, right? But I have to. That's kind of the rule. And so I'm bouncing back and forth with the pros and cons. But one thing I definitely want to mention with the cons is that in terms of security, people say, oh, okay, I can separate everything. The cloud provider lets me do that. Well, that's a lot of overhead, especially with stuff like credentials that can expire, certificates, etc. And while this all seems super, super complicated, it's totally doable, right? the biggest thing you want to do is basically coordinate your teams. If you can basically like walk together and move around together, then it'll all kind of work. You'll minimize the sort of pain. And actually, yes, that's the big sort of takeaway on the right-hand side here. Talk to each other, right? So, in person, chat, videos, issues, pull requests, everything. And on the left, a couple of technical takeaways that I tend to remind people. The triggers grow exponentially. I can't speak English anymore. I've lived in Germany too long. And so don't underestimate that sort of complexity. When it comes to how many repositories, how many pipelines, ask the people who are going to be doing it, who are going to be running the show, and they will tell you, right, how many they want. It doesn't matter what I want, right? People always ask me. No, what matters is what they want. And same thing for the level of complexity, whatever they're comfortable with, not what I'm comfortable with. And it's okay to promote your software manually by pushing manually or merging manually into production branches. I do that too. So last thing, you can find some of this code on GitHub. A lot of the stuff that I do is open source. I put it all out there. I'm not worried about secrets, etc. I also blog and I make videos on YouTube. So if you like any of these examples, you think they're interesting, and I totally sped through all of them, but you want more detail, let me know somewhere, GitHub, blog, YouTube, and I will, maybe make a video about it. Maybe because I enjoy doing it, but I have to find time to do it as well. So, all right, that's it.